Good morning, myself Yash Mishra, and today we will be solving some more questions in thermodynamics. And here the question is, so here the temperature maintained in this question is 35 degrees Celsius, which is given, and the waste heat to cooling condenser is at 18 degrees Celsius. Rate at which it is there, it is 0.25 kg per second, and the heat leaves at 26 degrees Celsius. And the refrigerants entered at the condenser, that pressure is given as 1.2 megapascal, and the temperature is 50 degrees Celsius, and it leaves at 5 degrees Celsius. In this the temperature is given, all these values we have to convert to Kelvin, and the pressure consumed is given as 3.3 kilowatt. Okay, and the quantities we have to determine the mass flow rate, refrigerant load, coefficient of performance, and the input power which is there. So these four things we have to determine, and these are the things which are given to find the values. Okay, so let's see what is the figure in this question. So the figure for this is this. In this, here it is a condenser, and here there is an evaporator. From here the heat is given, here the work is done, and the what was the pressure, 1.2 megapascal. Inlet temperature was this 50 degrees Celsius. The from the condenser it is going out at 26 degrees Celsius, and this is a water. Okay, water is used, and 18 degrees Celsius is coming in. Okay, and here it is a valve to change the values. Okay, so let's see the approach what we will use for to solve this question and find the values. So firstly, doing the energy balance in the condenser part. In the so here the condenser is this, so performing the energy balance here. So the equations are QH is equals to MR H2 minus H1. Okay, so MR will be MR H2 minus H1, and QH is also equals to MWCP TW2 minus TW1. So these two formulas of QH we know from the heat balance. Okay, so either the Q value is M M delta H or MC delta T. Okay, so these but the mass of these both will be different. So these two formulas of heat we know, M into delta H or MC delta T. Okay, so because H is equals to C delta T, so this we know applying this formula here. So the MR value will be equal to MWCP TW2 minus TW1 upon H2 minus H1. Okay, so MR came out, so putting the values, MW 0.25, CP value was given as 4.18, TW2 26 minus 21 upon H2 value 278.28 minus H1 value 110.20. Okay, so putting the values we can easily find what is the value of MR. Okay, so moving further, so QL is also equals to QH minus WE, or QH was equal to MR H2 minus H1. Okay, and minus WE. Okay, putting the value of MR 0.697, and H2 value as 278.28, and H1 value as 110.20, and WIN was given as 3.3. From this figure we can know that the W was given as 3.3, this power consumed as 3.3, so it was given. Okay, so putting all the values here, so we can easily get the value of QL. Okay, so this is the concept we use. MR in the previous question, MR is equals to MWCP TW2 minus TW1 upon H2 minus H1, and QL was equal to QH minus WN. So this same concept we use to find this second part. Okay, so finding the coefficient of performance, in this formula we have to learn that the formula is equal to coefficient of performance formula is QL upon WN. So putting the values of both QL and WN, we can easily get the value of coefficient of performance, 5.06 upon 3.3. So we can easily get the coefficient of performance. So last part, so in this the power we have to find. Okay, So performance formula as it is also equal to TL upon TH minus TL. Okay, so putting the value of TL minus 35 degrees Celsius, so minus 35 plus 273 upon TH minus TL. So 18 plus 273 minus 3, so 35 plus 273. So in the Celsius also we will put, so it will give us the same value as difference is there. So if we don't read but the upper value, we have to change to Kelvin, as in this the difference is not there. So we can easily get what is the coefficient of performance from this. Okay, when the temperatures are involved. Okay, so we know that the W is also equal to Q upon the coefficient of performance. So this formula also we have to remember, W is equals to QL upon coefficient of performance. Putting both the values, we can easily get the input work which we have to give, or the input power which we have to give. Input work is also equal to the input power which we have to give. Okay, and the formula, these two we have applied in this. This is the first formula, this is the second. This is the formula which we also used for the finding of the C part, and this is the formula. These two formulas we have to remember. But W is also equal to QL upon coefficient of performance, and the coefficient of performance formula is also there for the, when we know the temperature, two temperatures are known, then the coefficient of performance, how it is determined. Okay, thank you.